All right, so everyone eyes up here. So this should be the exact problem that you have for number 2 on that yellow paper. All right. So remember, when it comes to long division, it's just like if you were doing numerical long division. All right, it's the same process over and over and over again. So first things first, we're just going to set it up with our long division symbol. All right. So we're taking our big polynomial and dividing it by our linear binomial. All right. Now, does anyone remember the first step? Dylan.
4x cubed over 4x.
Right. So in other words, you divide the first term of your big polynomial by the first term of your linear binomial. All right. So I want to leave myself a little space, but I'm going to do it down here. So I'm going to do 4x cubed divided by 4x. What happens to the 4s? They cancel. And then what's x cubed divided by x? X squared. Remember, you're taking away one of the x's. And remember, you want to write it up top because that will be part of your quotient or your answer. Now, does anyone remember my next step? So we've done the dividing part. What will be the next step?
You multiply against the original equation?
Multiply to what part of the original?
The divider?
You're close. Not the divider, the divisor. S, yeah. So, why it's right, you would take the divisor, which is what we're dividing by, and multiply it to our x squared. All right, so Wyatt, if I distribute that, what is it?
I got 4x cubed and I didn't finish the 5x.
Well, it's negative 5 times x squared. Yep. Now, remember, before we can write it up top, because remember, we want to end up subtracting it, what do I end up having to do with those two signs? We switch them. So this would be minus, this would be a plus. So I'm going to write minus 4x cubed plus 5x squared. What happens to my 4x cubed? Cancels. What happens to my 5x's? They also cancel. So this is actually one where typically, one of them wouldn't cancel. This one actually does. All right. There's nothing wrong with that. We just kind of continue as normal, but we just have to bring down both parts now. All right. So if it ever happens that both things cancel and you still have things after it, just bring it both down. Okay. And it's still business as usual. So now I'm going to divide the negative 16 by what?
4x.
4x. Good. So down here, I got negative 16x over 4x. What happens to my x's? They cancel. So it's negative 16 divided by 4. Negative 4. Good. I'll write it up here. What do I do now? Times it by 4x minus 5. All right. So Mackenzie, what would I get when I do that? Good. Negative 16x plus 20. And then what do I have to do before I bring it up top? Switch the signs. This becomes a plus. This becomes a minus. So I'll write 16x minus 20. What happens? They both cancel. So my remainder is what? 0. So if I have a remainder of 0, do I need to do like the whole 0 over my thing? Why do I not have to do that? Why do I not need to put this? That's how we write our remainder. Well, 0 technically has a value. It's just nothing. But why can I not write? Why do I not need to write that? Anything divided into 0 is 0. But I could still probably do this. Why do I not need to write that? It adds nothing. So, does anyone know what that's called? It's actually a property. Saying that if you add 0 to anything, it'll just give you itself. Does anyone know what that's called?
0.
Nope. It's called the additive identity property. All right. Where the identity is 0. So all that means is if you add 0 to anything, 0. Same thing like if you multiply 1 to anything, it's itself. That's called multiplicative property, identity property. All right. So, in other words, x squared minus 4 would be your answer. Is it starting to ring bells again? Okay. So, let's have you guys do another one for practice. So, look at that pink sheet that you had to grab. Okay. For your pink sheet, I want you guys to try just the left column. So, only do the parts that say long division. Okay. I want you to try the first and second problems. Now, before we get into it, look at problem 2. What is kind of different about problem 2 in comparison to what we've been doing? Well, that won't change anything. What's going on with problem 2?
So there's no base, that's 3 numbers.
We're missing what?
There's only 3 numbers.
Well, there's only 3 numbers, but we're doing what? What exponents are?
Exponent 4.
We got an exponent 4.
It's
The
not
highest
four.
exponent doesn't have a leading coefficient.
That won't change anything.
It's not 4, 3, 2, 1.
There you go. So remember what I said on that one problem that we had last week. So on number 1 on your yellow sheet. What did I say your exponents have to do?
4, 3, 2, 1, 0.
They have to descend in order. So if your top exponent is 4, it needs to go 4, 3, 2, 1, 0, where 0 is your constant. Okay? So who remembers what I have to replace? Because I'm missing which 2 numbers here? Which 2 exponents? 3 and 1. So I need to rewrite this so that I have g to the 4th plus something g to the 3rd minus 3g squared plus something g minus 18. And still all divided by g minus 2. Well, what number do I use as the coefficients for the g cubed and the g so that it would still give us this if we simplify it?
0.
0. Remember, anything times 0, it goes away. So we use 0 as a placeholder. So remember, guys, anytime you start a division problem, make sure all of your exponents are going down in order and they're all represented. If not, it'll mess up your answer. Okay? So I'm going to give you guys about 5 or so minutes to try the first one. All right? So in the left column, I want you to solve the first one. All right? And I will be calling on people to walk me through it, so everyone needs to try it. Now, I'll give you guys about 2 or so minutes of just trying it on your own. Then I'll give you some time to talk with your group mates. And when you talk with your group mates, all right, if you have questions, I do not want you to ask me directly. I want you to ask your group mates first. And if all your group mates have no clue, that's when you ask me. All right? So I'll give you a couple minutes to try this. If you need more space, you can use the back of your paper too, because it's blank. So guys, try problem 1 for right now, but if you finish it early, you can go ahead and tackle problem 2. Guys, just in case you need it, here's the first problem as a reference that we already did together. Just so you have a reference. So guys, if you're completely stuck, I'm gonna ask you to put your pencil down so I know I need to help. Okay, looks like some of you are wrapping up that first problem, so we can use this time to collab with your groups. Talk to each other. See if you guys are doing the same stuff. If someone's stuck, talk through it.
What is not time? It is 19.
So I should be hearing some talking going on, guys.
Have to redo the whole thing. You know what? It's the first one. It's
Just not. Wait, alright, it's okay. Bro, what's your?
What? I got that too, bro.
I see it.
It's like the worst. I heard shriek before. Tyrek. High Shrek was Tyrek for like 2 years. So the first things you take, go take 6x, cubes, and then you divide that. So you take the first number right here. Oh. So take
So you kind of did it right, but
and it's basically the same as everything else. You just have to divide it into six x
come on, guys.
I got chips. I got chips. It's not good. So give me the AirPod. I want AirPod. Shoot, that oh, enjoy. What day is it? Are you really dead serious?
Okay, guys, I'm gonna give you another minute. Try to finish up your thought process. If you're done and you guys are good, you can start working on it if you want.
It's all that. What does that mean?
So this is actually an easier way. I always use the hard way first. Gotta scale up.
Wait, this side just catches it in the side, and that's just a bit the way.
This is completely different. All right, guys. So looks like most of y'all are wrapping up. So let's go ahead and discuss this. So I'm gonna have some people walk me through the steps. Now, to get us started, let's see who I want. Let's go, Leslie. So, what's my very first step here? Well, before I even do that, what do I need to do first? Right, I need to write out in the long division, which Miss Murphy needs to write small, but 6x cubed. Can someone just read it out for me? I don't have it in front of me.
6x cubed
Uh-huh.
minus 19x squared plus x. No, yeah, plus 6.
Okay.
Divided by x.
It's minus 3, yeah. Okay, now what do you do, Leslie? So 6x cubed divided by x, which would give you what? So 6x squared. So we write that up here. Shh. Then what do I do, Leslie? The divisor. So x minus 3. Good. So what would that give you when you distribute? Six x cubed and minus 18x. Good. And then before I can write up top, what do I have to do? Right. So I got to make this positive, this negative. So then what happens, Leslie? Uh-huh. What am I left with? Good. And then we just bring down the plus x. All right, Leslie, pick someone to continue. So pick someone. Anyone you want. Pick them. Who? Lainey? All right, Lainey, shoot. What's next? So we do negative x squared divided by x, which gives us what? Negative x. Good. Then what do I do? Multiply by x minus 3, which will give you what? Nope, it's plus 3. 3 what? Good. Then before I bring it up top, what do I have to do? Change the signs. So this becomes positive. This becomes negative. So this will be x squared minus 3x, which what would that leave you with, Lainey? Negative 2x. And then you bring down the 6. All right, Lainey, pick someone. All right. Mackenzie, what's my next step from here?
You would do -2 divided by
So negative 2x divided by x, which gives you what? Good. So I would write it up here. Then what do I do? Yep. Then
-2x plus 6 before you switch the signs.
before I switch the signs, good. So if I switch the signs, this would be negative, or no, that would be positive. This would be negative. So we have 2x minus 6. What happens? They both cancel. So what's my remainder? 0. So our remainder is 0. So 6x squared minus x minus 2 would be our answer. All right. How are we feeling about long division? You guys need to do that one more example?
Nope.
No.
Okay, well, let's just talk through it together then. So I still want to make sure y'all are solid. So let's do g to the 4th plus 0g cubed minus 3g squared minus or plus 0g minus 18. And it's all going to be divided by g minus 2. All right. So, Mackenzie, pick someone. Pick someone who's going to start us off. All right, so Julian, what's my first step for solving this?
Divide g to the 4th
Uh-huh.
by g.
Uh-huh. So we're going to do g to the 4th divided by g. Good.
Use your divisor. You would multiply that into your divisor, which is g minus 2.
Uh-huh.
You would get negative g to the 4th plus 2g to the 3rd.
So g to the fourth minus 2g to the third, and then you flip the signs already. Good. You're over here. Just make sure you grab that pink sheet from the front. This will be minus, this will be plus. So minus g to the fourth plus 2g cubed. So that goes away. And then what does that leave us with, Julian? Good. And then we do what? Not yet. There's one thing we got to do first.
Oh, bring down the.
Yep. There you go. All right, pick someone to continue on. All right, Jackson, what's my next step here?
You gotta do 2G to the third.
Uh-huh.
by G.
Good. So I'm going to do 2g cubed divided by g. And what does that give you?
2G squared.
Good. Then,
You do 2G squared times G minus 2.
good. So what he's done so far is he did the first term of our big polynomial divided by the first term of our linear binomial, or our divisor. You got 2g over g, which simplifies down to 2g squared. He then multiplied it by our divisor. All right. And remember, whatever you're dividing by, make sure you're writing that up top. So I got the g cubed from the first one, the 2g squared from the second one. All right. Jackson, continue.
You would get 2G cubed and then negative 4G squared.
Good.
You flip the signs.
Good. So that's negative, that's positive. So I bring it up here. So guys, essentially we're flipping the signs because remember, we have to subtract that entire polynomial to the top. All right? Because then that'll give us what we need to play with next. So the 2g's cubed cancel out. So what does that leave us with, Jackson? 1g squared. Then I got to do what? Good. All right, pick someone to pick it up from there. All right, Zach, what do I do next? Yep.
Okay. You would take
Problem 2 on that pink sheet.
G squared divided
So g squared divided by what? Okay, so first term divided by first term again.
by G.
Bg. Okay, so we get g, so I'm going to write it up here so I don't forget. Now what do I do? Multiply it by our divisor, which is the g minus 2. That's what we're dividing by.
G squared minus 2G.
Good.
And you flip the signs.
Okay, so this be
Negative G squared plus 2G.
all right. Now I'm going to swing this over a little bit because I didn't give myself enough space. So I'm going to rewrite g squared plus 0g, and then negative g squared plus 2g. So what'd that give me?
You would cancel out G squared.
Mm-hmm.
And then you would get instead 2G.
Good. And then what would I have to do? Right. Okay, pick someone to pick it up.
All right, so now you gotta divide this 2G by G.
Uh-huh. So 2g divided by g.
That's not giving you
It does, because the g's cancel.
then you do 2 times G minus 2.
Good. Now before we do that, I'm just going to write the plus 2 up here so I don't forget. Because remember, what you're initially dividing by, that goes into your answer. All right, so when you do your g to the fourth divided by g, or the 2g cubed divided by g, or whatever that answer you get, make sure you write it up top as part of your answer. All right, continue, Wyatt.
You do 2G minus 4.
Okay.
and then you sign flip them, it'll be negative 2g and then plus 4,
Good. So I'll write it over here. Negative 2g plus 4.
and the g's cancel out,
Uh-huh.
and you get negative 14.
And is that my remainder, Wyatt?
Yep.
Yep. So how do I write my remainder in my final answer?
You do 14 over g minus 2, or negative 14 over g minus 2.
Right. We take our remainder, so it's negative 14, and we divide it by our divisor. So that signifies that we had something left over, it just didn't go in nicely. So this would be our fraction. Now, that's a whole lot. All right. Now I'm going to show you an easier way. And it's all by synthetic division. So synthetic division is another way that we can do essentially long division, but it's cleaner, I think, and it's a lot less steps. All right. But there's really a lot of special cases that we do with it. So what we're going to do is I'm going to show you how to do synthetic with the first problem that we just did. All right. I'm not going to have anyone walk me through it. I'm just going to show you the steps. All right. Then I'm going to have you try it with the second problem. Okay. So let's go back up to the first problem that we just did. So problem 1, we're going to show it with synthetic division. Now, with synthetic division, all right, we set it up using the coefficients and the root. All right. So x minus 3. What is x minus 3 technically? So we talked about this last week and we were doing all the different graphs and stuff. What would x minus 3 technically be called? A what?
A point.
Nope. Starts with an F. A factor. Good. So x minus 3 is technically called a factor. Does anyone remember how to get the root? Well, it's already factored. That's a factor. Does anyone know what a factor is? Anyone want to take a guess at what a factor is? So a factor has something to do with multiplication and division. So I'll give you guys a hint. 5 is a factor of 25. 3 is a factor of 6. 4 is a factor of 32. What do they all have in common?
They multiply into it.
They don't multiply into it, they can
Divide.
divide what?
Drawn a blank.
Evenly? See what's going for? So, in other words, guys, a factor is a value that when you divide it into another value, it comes out evenly. So, in other words, a remainder of 0. All right? Keep that in your brain because we'll talk about that in a second. But that means that to get the root, which remind me what a root is? It's an x-intercept. What else is it known as? So the root's an x-intercept. What's another name for it?
Factor.
Nope. Starts with an S. That's what we typically want in this class.
Satisfactory.
Solution.
All right.
That was so much more.
All right. So how do I get my root for my factor? So I have the x minus 3. How do I get that root?
You solve it.
Set it equal to 0 and then solve it. So if I add 3 to both sides, x would be equal to 3. So 3 is my root. Now, why is that important? That is the basis of my synthetic division. So the first thing you want to do with synthetic division is find that root, because what you're going to do is you're going to put it in a little box up in the top left. Now, the next thing you want are the coefficients of your big polynomial, but you also need to make sure that all the degrees are represented. So in other words, all the exponents from 3 to 0 are represented. That's true here. So if I look at the exponents, all the exponents from 3 to 0 are represented.
Yes. No.
Yes, they are. So this is 3, 2, and 1.
Right, what's the unspoken exponent here?
No.
1. What's the unspoken exponent here?
0.
0. So
Yes.
it does go from 3 to 1, 0. So since they're all represented, we know we're good. We don't have to replace like anything with like 0x or whatever. Okay, you don't have to put any placeholders. So who remembers what a coefficient is?
6.
Well, why is that a coefficient? What's
Last
a,
exponent.
Number before the variable.
it's a number before the variable. That's what a coefficient is. So
That's what I said.
guys, I'm using vocabulary because you're going to hear it a lot. You've been hearing coefficients since math 1, at the very least. All right? So I just want my coefficients. So what would my coefficients be?
19, 19,
6, negative 19, 1, and I'm missing 1. So even though, right. So even though that last 6 doesn't have a variable, it's still considered a coefficient because remember, it'll be 6x to the 0 power. All right? We still consider it a coefficient. Now, I'm then going to draw a line. All right? Now, with synthetic division, it's just a lot of multiplying and adding. All right? So if you can multiply and add, you're golden. All right? Your root is what you want to multiply by. So this is always what you're going to multiply by. So that's why the root's pretty important. So my first step with synthetic division is I need something to multiply the 3 to. So I'm going to drop the 6. Meaning I'm going to drop the 6 below the line. So the numbers below the line are the numbers you're going to be multiplying to. Now, I'm then going to multiply that 6 by 3. What's 6 times 3? 18. So I'm going to write the 18 above the line now. Now, in order to get my next number below the line to multiply the 3 to, I need to add these two numbers together. So if I add negative 19 and 18, what do I get? Negative 1. And then guess what I do now? What do you think I'm going to do? Multiply again. So in other words, we repeat the process. So just like with the long division, once we complete one round, we can repeat. So I'm going to multiply the negative 1 by 3, which is what? Negative 3. If I add them together, what do I get? Negative 2. Repeat the process.
0.
So negative 2 times 3.
negative 6.
Negative 6, and then we would get the 0. Now, here's my question to you guys. Look at the numbers or the coefficients of our answer in the long division. And then look at the numbers that we got below the line. What do you guys notice? So look at the coefficients of our answers from the long division. And then look at the numbers we got below the line. What do you notice?
They're the same numbers without the x's.
Right, they're the same numbers with the same coefficients. They just don't have the variables yet. All right? That's essentially what synthetic division does. It gives us the variables. Not the variables. It gives us the coefficients. And then we just need to add in the variables. Now, what does the 0 represent? What do you think? The remainder. So what I like to do sometimes is I like to draw a line in front of the last number just so I know that this number is still my remainder. Now, you may be wondering, okay, well, if I didn't do the long division first, how would I figure out the variables that go after these? Okay? Very, very easy. All you gotta do is look at your highest exponent of the original polynomial. So this is 3. Okay? all we have to do is just subtract 1 from it. All right. So 3 minus 1 is what? 2. So that means our first variable to go with our first coefficient, so the 6, will be followed by an x squared. And then from there, we go down the line. So what variable do you think is connected to the -1?
Why did we subtract 1 from the exponent again?
That's a good question. Okay. So think about it. We're dividing. What was the first thing that we did here in the long division?
Divided.
Divide what?
6x by x.
So 6x cubed divided by x, right? So if we divide x cubed by x, what does that become?
Oh, x squared.
So basically, this is just telling us that if we did it long division, we would have already been taking away one of the x's anyway. So that's why we subtract 1.
Did we do that for everyone?
Mm-hmm.
Okay.
So every time you do synthetic, you just subtract 1, and then for the rest of your constants, you just go down the line in order. So 2, 1, 0. All right, so it'll be my next variable connected to the -1. X. Then would anything be connected to the -2? Nope. And then our remainder was 0, so we don't need to add anything extra. And that's all we got. So essentially, these steps for synthetic division, and it's written up here. You find the root of the divisor. So set it equal to 0. Set the divisor equal to 0. Solve it if you need to. Set up the chart using the root and coefficients. And remember, if you don't have all of your exponents represented, use zeros as placeholders. All right? Bring down the first number. Multiply. Add, repeat. Write the quotient. And remember, you divide it by x, so you start 1 degree lower than when you divide it by the last value is your remainder. All right? Now, here's my question to you guys. If you notice with our long division, the steps are pretty much exactly the same except for 1. All right? In other words, the division's kind of already done here. But we multiplied and then subtracted over here. But we multiplied and added over here. Why do you think I added here instead of subtracted? Does anyone have a thought on why that is? Even if it's completely wrong, does anyone have a thought on why that is? It's okay. We're just throwing some stuff out there. Mackenzie.
Did you add because whenever you times the 6 by 3, it would still be positive? Same with the -1, but it would be a negative.
Well, that is true. So we're timesing by a 3, so we would just kind of be combining here. But why do you think we would we subtracted over here, but we're adding here? Why do you think that is?
Because the division and subtraction is connected on that side, and then the multiplication and add and subtract.
I mean, it's a good thought, inverses of each other. All right, that is part of the answer. Something to do with inverses. I'll give you a hint. Look at the divisor versus the root. So our divisor is x minus 3, our root is 3. What's different?
The 3 is negative, and the divisor is negative, and then the root is positive.
Right. So in the divisor, we have the x minus 3, which, if we multiplied it over here, when we multiplied whatever we got divided into it, we would get a negative number or an opposite sign number. Whereas here, since we already took care and found the root, the inverse was already done for us. So in other words, when they had to flip signs over here, we don't have to worry about that now. All right? So that's why we're adding here instead of subtracting. Okay, that's why this works. All right? Now, any questions on the step process? Yes.
For now, we do the remainder over the.
The remainder will be written the same way. Yes. So if this was a remainder, like of like 2 or something, you'd still write it as plus 0 over x minus 3. All right, you still write the remainder the same way. Yes. All right, so what I want you guys to do now is I want you to try by yourself for about 2 minutes the second problem using synthetic division. So you already know what your answer is supposed to be for the second problem. Now try it with a synthetic division, see if you can get the same answer. Tyreek's next, and you can go. All right. So I want you to work for about 2 minutes in just silence. And then I want you guys to talk with your roommates and compare answers. So you already know what the answer's supposed to be. Now see if you can get it using synthetic. It depends. So that actually brings up a good point. So guys, with synthetic division, real quick, synthetic division really is only user friendly when your A value of your divisor, so in other words, the coefficient in front of your first term of your divisor is 1. All right. So like this value right here is technically a 1. That's when synthetic is nice. Now you can do it when it's another number, but it's just a lot ugly because you deal with fractions. All right. So long division is actually easier when you have an A value greater than 1. But if your A value is 1, definitely use synthetic. Yes, sir.
We have to do the, like we did when it gives you 0 to for the synthetic, right?
So, but like, is it not 1 or is it 0? Because if it's 0, then 0 times 0, and 0 times 2.
What?
So remember, you drop the 1 first.
Wait, but I thought,
But I go.
so these are 0.
So don't forget to put in your zeros for your coefficients, for your placeholders. Just like you did with your long division.
So it should be like 0 here. Every single.
Please don't use the 1.
You just have to have the zeros for places.
Okay. And then we just so there's 1 times 2. 1 x times 2.
And Adam.
2.
And T.
Okay. You drop the 1 and you divide by 2 and you subtract by that. And then you do the same thing. So,
Yeah, I guess it's a 0. So you gotta write
it says here,
Because like I look at English,
That's
that's true. I can relate to English concept. Yes, actually.
So if it's not,
What's the answers for the one? The first one, like that. I don't know.
JC, like before. Yeah.
So that's.
We get there to be minus. Times 2 and minus.
Yes, three.
Oh, wait, no, it's 2, it's 2, it's 2.
1 times 2 is 2.
That's what I was saying.
Joe, why don't you say over? It's multiply add.
So if you're multiplying.
Well, 0 plus 2. So 0 plus 2. Right now.
I'm saying it's like, so if you're like this one, it would be a negative, and that would be a negative.
Yeah.
What was the answer for that? Problem 2 for the negative one?
Is that? So, guys, you know what your answer should be for the second one. All right, from our long division. So, check that with what you do with the synthetic. If it's not the same, you probably did something wrong.
Breaking people's houses.
Whatever's wrong.
I don't even know what he is. Okay, that makes sense. So, wait, so we have four. Multiple times.
Only to erase it 3 times. Maybe I'm not sales. What? Then beating on the sales.
So 1, 0, negative 0,
All right, guys, I'll give you one more minute. You can start discussing with your group if you haven't already. Compare answers. Make sure you guys got the same thing. So compare answers within your group. Make sure y'all are good.
Everyone's close to.
And if someone got stuck, work with them.
She literally said.
So like say
You're trying to.
two,
I'm friends with somebody else.
you put second for 0, it's not.
Where did you get a second? So then you so probably using this now. Doesn't have enough information.
Because it's gone pretty much out. It's very.
The opposite. I'll take it when you win.
It's just.
All right, so let's come back together because I looked around. Most of y'all were pretty good on this. So Wyatt, you ended us last, so pick someone to pick it up. Someone preferably who has not talked yet.
No.
Which one?
No.
All right, so Dylan L, what you got? How do I start this?
You gotta get the, you set equal to 0, G minus 2 equal to 0.
So I gotta set my divisor equal to 0. Okay, and what is that 2? It's our root. Right. Then what do I have to put up top? Shh.
You gotta put those those the coefficients.
Which are
0,
that's
1, 0, -3, 0, -18.
and why'd you put zeros in there?
Because you had to make up for the missing numbers. In the equation.
Right, we gotta make sure all of the exponents are represented from 4 to 0. So if they're not, you use zeros as placeholders. All right. All right, Dylan, pick someone else to pick up from here. All right, Tyreek, what do I do next?
You bring the 1 down,
Okay. Then what do I do?
multiply the 1 by 2.
So you multiply the 1 by your root, which gives you what?
2.
Then what do you do?
Subtract 0 by 2.
Not subtract, we
Or
add. So 0 and 2 is?
2.
All right, pick someone up to pick up.
I
Someone who has not talked yet.
don't really know like their names.
Point to someone and I'll tell you the name. All right, Peyton. All right, and that gives you what? Then what do you do? Good. All right, Peyton, pick someone to pick up. So Layla? All right, Layla, what do I do next?
You take the 1 and you multiply it by 2,
Uh-huh.
and then it's 2,
Uh-huh.
and then you put 2 under the line.
So in other words, what we do with the 0 and the 2? Good. All right, pick someone to pick up.
All
right, Caden, what do I do next?
You gotta multiply the 2 by 2.
Uh-huh. Then?
And then you get 4. So then you add the 4 to the -18.
Uh-huh.
You get -14.
All right, and what's so special about that -14, Caden? My what? It's my remainder. Now, I'm not done yet, so Caden, get someone else to pick up. Really some.
I just went.
No, someone who hasn't talked yet, please.
How about Julian?
Julian's talked.
Yeah,
Yeah, Julian.
got it.
All right, Frederick. So how do I finish this up? So I got all of my coefficients. How do I write it so that it looks like what I originally got with the long division?
You add your G to exponent.
All right, well, how do I know what exponent goes with the G's? So what would the first exponent be? So it wouldn't be G to the 4th, it would have to be what?
G to the third.
Right. So remember, you take the highest exponent and subtract 1 to it. So our first one would be 1G to the 3rd. So what would my next one be? 2G squared plus, and then how do I write my remainder?
-14 over G minus 2.
Good. Good. And we got the exact same answer that we originally did. All right, any questions on synthetic division? Now, I want you guys to still have a lot more practice with synthetic division. So what I want you guys to do now is take out your packet and turn to page 9. So take out your packet, turn to page 9. And what I want you guys to do is, I want you guys within your group talk to each other and work through letters A and B on your own. Now, you don't need to do the right side, so all that evaluation on the right side will come together and do that. I just want you to do the division. You can either pick to do it with long division or synthetic. All right? So, in your groups, I want you guys to work together and figure out what the quotient is for A and what the quotient is for B. All right? Yes. If you need to, yeah. So you're on page 9. Did you lose your packet?
I don't even know.
Here, child. So talk with your group mates, work through A and B, and again, you can pick a method. You can either do it through long division or synthetic. You guys pick.
For example, John, for example.
Sorry, Don.
I do know. I just always like. That X, Y, especially X, Y. Although it wasn't bad. The group number.
It only works. Right now. So guys, pick a method and stick with it. So either pick synthetic or long division to do these. It's up to you. It's whatever you're comfortable with. Doesn't matter. You should get the same answer whether you do synthetic or long.
That's what I got. Magic of math, fellas. What is no. I love when you just have one girl that's actually good at the rest of it. Coiled. WC.
What's that mean?
It's so cool.
Sorry, I have a whole 10 things left.
All right, my mom, so.
Oh, we're not.
What? You what?
I saw her about this.
What? No, that's you. So we're not gonna talk about the weight balances yet?
No,
Oh my God, I don't think that's.
Your last number is always
That's how it's been.
It's always your
Somebody only uses. He's ambidextrous, oh my God. It's like perfect practice. He's gonna do He's a one-on-one.
Here, one chick pony.
A one-trick pony. Construction, what does that mean?
Yeah, no, one
That's what it's easier.
Like I said, you can use synthetic or long, both work. Long visual work every time, so synthetic really only works with the AI. Otherwise, you're messing with fractions. I mean, you can do it with other A values, like of the divisor, like say with like two divisor. You just don't fractions.
Where did you get 7 times 5 at? Oh, you're thinking
Bro, so you're making a mistake now, you're distracted. Next year. Wait.
Alright, guys, looks like most of y'all are wrapping up the second one, so I'll get you about another minute.
Yeah, I think my movie is like a 5.
That's a window going. There's a big 57.
Dude, I remember wondering how somebody, I was talking about them with my friends, and they said something that was like, is asking about that.
It's pretty much all right, you just kind of one minor.
I just be sitting there just like, fucking.
Hey, you're the rest of my kids back.
Jackson's next to you, Joe. Alright guys, so let's do this to save us some time, so I can see what you guys put. I want the oldest person in your group. So the oldest person in your group to take your 2 problems and write them out on the board what you did. So prepare for birthday. So whoever's older
I turned 17.
needs to write it out. And remember, it's groups 1, 2, 3,
You're the oldest.
4, 5, 7.
Oh, wait, 6. Okay, but you look 40. What table are we?
You're 5.
Okay. This guy does not look like he's 12, bro.
Of course, Julian's oldest.
What?
I'm only 16. I'm only 16 too.
I just said the oldest. I'm just talking by
He's old.
He's the oldest.
I got pull up a power squad.
So what are you talking about, bro?
I was born today. In 2008.
It's your birthday. Okay.
Are we, am I the 6th?
Still being negative 4.
Am I here?
Yes.
I only have no.
I got called an uncle.
Somebody else.
So, Mackenzie, show you guys work. So I want to see answers and work.
You read. How did he get worse?
No, it's not.
Okay.
not readable thing to us. I'm
So
just.
don't even start, yours is even worse.
Yeah, but don't even.
Mine's not that bad.
Yours is hieroglyphic.
Mine's readable. You write in 0.1.
Okay, but at least
You just divide it by whatever you divide it
at least mine
by.
isn't.
Just the 6.
Mine's readable.
I'm writing slow motion.
Yeah, just the plus 6.
So the only thing is because you're dyslexic ass can't read. Oh, snap.
And then what else? That's it. That's it.
How much? You're still the last person to be talking about that.
I'm not.
Okay.
Unbelievable. Hey, you want making Julian Dolly work for you?
That's his work. Why am I even saying?
Because it's your.
So this person is running my family board.
No, what is that?
Yeah, I'm 16. And my birthday is in August. Why is like 14?
15. God.
I don't know why it's like 14.
Yeah.
Wait, Jackson's only 16.
Yeah, his birthday is in September. And mine's in August.
Just by a month. All right, guys. So once you finish, have a seat. All right. Julian, keep finishing up, but. All right. So, Dylan, give us a good shake, and then read the top of it up on top.
6.
All right. So group 6. Tell me what you did for A.
Run down the 1.
So you did what type? Synthetic or long? Guys, shh. So what was your root? How'd you know that?
Because it's x minus 2.
Right. And then how'd you get the numbers across the top?
From the x squared minus 8x equals 2.
So they're the what?
1.
What's the vocabulary words for those numbers? What's it called? You can call a friend in your group. Coefficient. So it'd be 1, -8, 18. Then you drop the 1. Then what'd you do? Times it by 2 and got? Then?
I minus 8 from the, I minus, I added the 2 from the -8,
And got?
-6.
Then?
Then times that by 2 and I got -12,
Okay.
which got me 6.
Yep. Positive 6. Yep. Okay, then how'd you get it with variables?
I just put x since when in long division, the first number you get.
Right. So in other words, if you looked at your highest exponent, subtract 1 to it, it would just be exponent of 1, so just x. So-
X minus 6, and then it would be 6 over x minus 2.
Good. All right. Mackenzie, give that a shake. Tell me the first number on top.
1.
All right, group 1. Yes. Yeah. Well, who was after Jackson? Okay, after Julian. All right, so group 1. Someone explain to me how they got it. Which was? So did you use synthetic or regular? Okay. Uh-huh. Uh-huh. All right. Multiply it by 7 and got? Uh-huh. All right, now pause there. Skylar, pick it up. Uh-huh. Okay. Then what do you do? Uh-huh. And get? Uh-huh. Good. And then how do you get your not your coefficients, your variables? So these are your coefficients. So like that's what these numbers are, they're your coefficients. How do I figure out what variables go with them? So we look at our highest variable and we do what? What do I do up here? Right, we subtract 1. So what should my first coefficient, what variable should it have with it? We subtract 1 from the 2 up here. Right, so it'd be x to the first, right?
Yeah.
Which is what? So x raised to the first power is just x. So you'd have x, then what's connected to 5? Anything? All right, so plus 5. And then how do I write my remainder? Good. All right. Now, there was a reason for us doing all of that. You'll see in just a second. Now, the next thing we're going to do is using that same dividend. All right. So using that same dividend, which was what we started with or what we were dividing into. Okay. We're now going to find P of 2. Now, this is review from Unit 1. If we see P of some number, what does that mean we're doing? Plugging it in for what? X and evaluating. Good.
Can you give me my packet, please?
It's right behind.
It's behind you.
Oh.
Thank you.
All right, so I'm going to plug in 2 in for X. So 2 squared minus 8 times 2 plus 18. All right, so what's 2 squared?
4.
Yeah, thank you, 4. What's negative 8 times 2? Negative 16, and then bring down the plus 18. Now, by order of operations, we're doing the addition subtraction starting from where? Left side, so left to right. So it's 4 minus 16. Not just 12, but negative 12. And if I add 18, it'd be 6. Now, what's so special about part A and the second part? So part A, and then what we did on the right side. What's so special about it? Can someone see any connections that's going on here? Same. Right, so we have a 6 here and a 6 here. All right, that may just be a coincidence. But what else? What did I start with? So I start with a 2. Why do you think I plugged in that 2? What's my root? 2. So keep that in mind. Let's see if that still floats. Okay. So let's look at part B. So if I do P of 7. So in other words, I'm going to plug in 7 in for X. All right, I get 7 squared minus 2 times 7 minus 25. Any prediction on what this is going to be before you actually evaluate it?
10.
So I heard 5, I heard 10. All right. Let's see. Okay, 35. Let's see if this holds true. So what's 7 squared? What's negative 2 times 7? Then what? And then bring down the minus 25. 49 minus 14 is 35. Minus 25 is 10. So what's the connection? It's the remainder. Now, did I actually plug in the root? So in other words, when I did p of some number, was that the root?
Yes.
Yes. So this is what we call the remainder theorem. So a lot of times, yes. So remember, this is the factor. The root is when you set equal to 0 and solve for x. That's the difference. All right. Now, since this is what we call the remainder theorem, and all the remainder theorem is that if you know the root, all right, so you're given a factor, you know the root. If the question asks you, what is the remainder of this, you don't have to do all the division, all right? All you need to know is the root in the original, because if you plug the root into the original for x, you'll get the remainder every time, all right? And we know it's true because we did it, all right? Here's the remainder here. Here's the remainder here. It's exactly what we got for our answers here, all right? So if we look at the more formalized notes, okay? And we'll do this very quickly because remainder theorem is not very hard, okay? All remainder theorem states is that if you're given p of x, so that's the dividends, what we're dividing into. So you can just note that this is the dividend. And you divide it by some linear binomial, so x minus a, where a is equal to your root. You'll get some quotient plus p of a, or p of your root. So in other words, you plug in your root in for x, which is also a fancy name for your remainder, over x minus a. All right. So for example, like if I'm just breaking down the answer, let's say I broke down what we just did in the previous page. Okay. So I had, for number letter B, x squared, what was it? Minus 2x minus 25, all over x minus 7. That'll be equal to x plus 5 plus 10 over 25. Was it x minus 5? No, it was 5. Okay. So this part would equal my p of x. This part would equal my x minus a. So that means that a is equal to 7. All right. This part is my q of x. So my quotient. This part would be my p of a. So in other words, or p of 7 in this case. And this part is again x minus a. Now, the reason I'm bringing this up is this is something for the EOC. The EOC will put this notation in there. And they'll say find q of x, or find p of x, or find, not p of x, they won't ask for that, or find r, or whatever. All right? Make sure you understand what that notation means. Okay? Now, one last thing I want to note, and then we'll be done. All right? Because we're almost out of time anyway. A factor. Okay, so when we were talking about factors, what was always true about a factor? So why was 5 a factor of 25? They divide evenly into 25. The same is true for polynomials. Sometimes what we divide into is not considered a factor. So technically, some of the ones that we divide into, like for example A and B, were not factors of the original polynomial. All right? What do you think would happen if we had a factor? So how do we know if a linear binomial is a factor of a bigger polynomial? I'll give you a hint. It has something to do with the remainder. So think about what makes 25 and 5. What makes 5 a factor of 25? If I divided 25 by 5, what will my remainder be? My remainder would be 0. So if I did 25 divided by 5, I would get 5. 5 times 25 is 5. I have a remainder of 0. All right? That's how you know if you have a factor. It will give you a remainder of 0. So for example, that first, I think it was the first example on your pink sheet, that would have been a factor. All right? So by definition, if you have, guys, write this down, you're not done yet. If you have a remainder of 0, then x minus a is a factor of p of x. And again, you can find that using the remainder theorem. All right? So, for example, on your test, if I asked you, is x minus 2 a factor of x squared minus 4x plus 4? All right? And I just pulled it out of my butt. All you would do is find the root. So, find the root of x minus 2. Plug it into the bigger polynomial. See if you get 0 when you evaluate. All right? And we'll pick this up a little bit more tomorrow. Like we'll do 1 or 2 more examples on this tomorrow. All right? Now, I know you guys have 5 minutes left in class, so don't move just yet. You should now be able to finish your 3.3 delta math. So your 3.3 is everything long division, synthetic division. All right? All right, so you guys can go ahead and pack up. If you guys would kindly put your name tags in the turn-in box for me, that'd be great. And make sure your calculators are put away. Oh, so next period you're 17. I guess I'll have to remember that and just pull up. Word from the wise, my dears. Don't say it in front of the